Hello and welcome back to the Architecture Weekly number 54. In this issue, we're comparing MySQL versus PostgreSQL databases, doing a gentle introduction to domain-driven design, and figuring out how asynchronous computing changed over the time at Meta. Let's go! Don't forget that already tomorrow I'm interviewing Uwe Friedrichsen about the architecture trends in 2022 and what we should expect from software architecture in 2023. We're going to talk about the security, resilience, observability, and other trends in software architecture. Make sure you subscribe and you will get notified about the broadcast going live. When you ask yourself what relational database you need to pick for your new fancy project, you would probably name some databases like MySQL, Oracle, MySQL, PostgreSQL, and some more. How would you compare the choices? How would you pick the exact one? So obviously, you will want to see what the data types are supported in those databases, what indexing capabilities the database have, what is the performance of those choices, what are the replication capabilities, what is the support for the transaction, isolation levels, and many more. So first highlight for today's issue is the article comparing MySQL and PostgreSQL in 2023. It also shows that the current process of the migration from one to another is in favor of PostgreSQL, and you definitely want to figure out why, so grab the first link in the issue. I touched on the domain-driven design topic several times in both the blog and the newsletter itself. If you're new to a topic, you want to refresh your knowledge, or you're just not sold whether you need to read a book on the topic, then you will definitely appreciate a lengthy article on the introduction to DDD, which basically covers the content of Learning the Domain-Driven Design book by Vlad Hononov briefly. What's good about it, it has a healthy dose of funny memes which really improves their reading experience, so grab a second one. And the last highlight for today is asynchronous computing at Meta. So Meta has tons of data, and they prefer to handle their workloads asynchronously. So they built their own ordering queuing system called FOQS, Fox. What does the fox say? And deployed a component called Dispatcher that would manage the ingestion of the data into it. Although it is working fine, the team noted that Dispatcher incorporated too much of a responsibility for consumption, rate limiting, routing the workload, and many more. So what they decided is to improve the asynchronous layer architecture, and they shared how they did it and why. Personally, I understand the problems they face, like retries with streams, delays, but really, why would you reinvent the wheel? Why wouldn't you just pick several streaming solutions that are pretty successful out there? Well, if you wanted to, grab the third article in the newsletter. Okay, and it's time for the follow-up section. And the first one is unlocking the power of Service Mesh. Service Mesh is an idea of adding the common features of your microservices, not by the libraries, but by runtime components running alongside the actual service. So if you want to add observability or authentication or traffic management capabilities to all the microservices, then you could go with some runtime component that is essentially a sidecar for every of your microservices. But with all those traffic management, routing, and security features that meshes bring, the complexity of those solutions grows as fast. So please find the 5-part series of articles on the service meshes, which guides you through the introduction to service meshes, names a few examples, and demonstrates their internal architecture and working principles. Okay, the next one is the list of books for software design. So books are great, read them to improve your knowledge. And learning and mastering software design comes not only with practice, but also knowing the theory. So grab an article with 8 books that you might appreciate to build better applications and more robust systems. Okay, next one is as short as the previous. So this one is on idempotency. Exactly once is a holy grail of events-based system, and you possibly cannot have this in general besides some edge cases. But you definitely can help the issue if your event handling is idempotent. So that means that receiving the same event the second time won't affect the state of your system. So get a short note of the explanation in the serverless land blog. Okay, another short note, but this time on actors. Basically, the author of the post tells the story of transitioning from the arbitrary procedure-style way of implementing a synchronization lock to an actor-based implementation, where you send the events from several computing instances in async manner and letting another instance handle them, thus removing the performance constraint. So just grab more details inside the article. Okay, last one for today is the critique of the Spotify model. Team organization is frequently a part of an architect's job. You might have heard about this Spotify's model with autonomous, cross-functional teams, and people really misunderstand the principles of those. They don't know what level of autonomy they need to allocate for their teams, they don't know how to support the proper technology alignment across the organization, and have many other troubles. So this article, recommended by Martin Fowler himself, is here to clarify those misconceptions. If you missed this week, I posted an article on the continuous security for my patrons and Boosty followers. This article would possibly go public in a couple of weeks. If you want to access the content earlier, you can definitely consider following me on Patreon or Boosty. And of course, you can do the same to support the newsletter, of course, just in case if you like the content. But in any case, make sure you're subscribed to the channel, you like the content, and of course, leave a comment to give me some feedback. Thank you very much, and see ya next week.